In this video, we're going to talk about how to graph polynomials, right? Something that might look kind of like this when it's given to you in factored form. All right, now there's a few things that we need to talk about before we can graph this. And that is, what is the end behavior of this polynomial? What are the zeros? What are the multiplicities? And how are we going to use those when it comes to graphing, all right? Then there's also a couple other things we're not going to get to in this video. It might be in another one. But that is how to find the turning points. We can figure out how many there are, but we're not going to tell you kind of how to find those in this video. And then also, same thing with the y-intercepts. And that might be in my next video. All right, so let's look at this first one here. It says negative x squared times the factor of x plus 4 times, and then this is a factor of x minus 5 squared. All right, notice I said that these are factors, meaning that we've done other videos where we find zeros of things. And so we're going to find the zeros of these factors, and I can set each of those equal to 0. In fact, you might even get this in the form of f of x equals that polynomial equal to 0, and then you can factor it that way. So again, each of those would be equal to 0. Let's try it. If I say negative x squared equals 0, well, if I was going to solve for x here, I could divide by a -1. 0 divided by -1 is not going to change that. So it's just going to be x squared equals 0 still, and then take the square root, and of course we're just going to get 0. So one of my zeros is 0, all right? And then the other ones, I think we can do this one relatively easy. If I were to subtract 4 over, that would give me an x of -4, right? And then this one, again, since it's being squared, don't get too worried about that, but that's x minus 5 squared equals 0. And really the square is going to go away, so I might not do as much with that in the future. But if I were to add 5, I would actually still get x equals a positive 5, just like it would be without that square. So I have 0, 5, and -4. I'm going to write that over here, and we'll get to the end behavior in a second, but we'll have 0, 5, and -4. All right, and then give me a second to erase this, because now we need to talk about the end behavior. All right, there's really just two kind of graphs that you need to think of when it comes to end behavior, and that is y equals x squared and y equals x cubed. All right, everything else is going to be kind of a derivative, or kind of comes from those two. If it is going to be an even power, then it's going to start up and end up, as long as this is also positive. Right? We know if this was negative x squared, then it would flip down. All right. So ours, if we think of how many degrees we have 2, 3, and then this is 4, 5 with those. So ours is going to look probably more like this x cubed, where it's going to start opposites, either start up and go down, or start down and go up. And the graph y equals x cubed itself, this graph, it's going to be, I think we remember this one maybe when we do our families of graphs. It's going to start down and go up. But again, if this was negative, in front, if I were to put a negative there, then it would start up and go down. All right, so what's ours? Ours is negative, and we said there's 2 x's, 3, then 4, 5. So it's going to be kind of a negative x cubed one, which means it's going to start up and end down. All right, again, let me get that erased, and we'll try the next part. All right, so for this next part, I drew a graph because we're going to use it to help us find the multiplicities. And multiplicities, what this means is just if there are multiple of the same factor. All right, if it's, again, an even one like this is x squared and a -5, or x minus 5 squared, I should say. If those are even, these are going to kind of hit those zeros at 0 and 5. They're going to bounce off. All right, and we have to know kind of how it's going to affect this along with the end behavior before we actually graph it. All right, and then in our next video, we're also going to talk about where it hits the y-intercept. Okay, so with all this said, let's go ahead and plot these on here. We have a 0 of 0, of 5, and of -4, like this. We know that it's going to start up and end down, so it should be up here somewhere, right? And it might do some wiggling through here and then end down, like that. And with this, let's kind of see what would happen. So at 0, it needs to bounce off. So I might circle this one to remind us of that. And also at 5, this is a multiplicity. So in fact, I'll say 0 and 5 are those. Circle that one to remind us as well. But it can actually go through our x-axis here at -4. And so if we kind of follow along what would happen, I would go through, right? So I'll mark this up in a second. And I'm going to come up and I'm going to bounce, go back down, come up and bounce off this one. So it's not going through those, and then it would end down. So kind of mentally do that little checklist until you kind of start up and end down like you should. Do you hit all your zeros appropriately? Yes, we do. And so now we can go ahead and graph this, all right? Now this is just a rough sketch. Again, it might be higher or lower in some spots than I go. And again, we might get to that in other videos where that's called the turning points. But for this one, it's just kind of a rough sketch knowing where it's going to go through. So it's going through at -4. It's going to come back up and bounce so it doesn't go through. And then come back up and bounce again off of the 5. And then it'll end down like that. Okay, that is how you would graph this polynomial. Let's try maybe one more. Okay, for the second one, we have a polynomial that says f of x equals x times x minus 3 times x plus 2 quantity squared. All right, so I'm seeing a couple things right away. I have some nice zeros as well as I should say a multiplicity one there. So first, before we do anything, what is the end behavior of this? How many x's do I have? And what is it going to be doing? Going up, down, whatever. All right, so we got 1, 2, and then this is 3, 4 because it's squared. So I have 4 x's, which means this is going to be a degree of 4. All right, so it's either going to both end up or both end down, depending on whether this is positive or negative. It is positive, it's a positive x, so we're going to start up and we're going to end up like that. My zeros, well, x equals 0, nothing with this time, so it's just going to be a 0. A positive 3, if I were to set that equal to 0, and then same thing over here, a negative 2. So let's go ahead and plot those. We have 0, 3, and negative 2, just like that. And again, I have to end up and end up on my graph. I am the worst arrow drawer in the world, I think. All right, there we go. Multiplicities. So we just have one, and it's going to bounce off at negative 2. Remember, I could set that equal and get the negative 2 there. So I'll say at x equals negative 2, it's going to bounce. And so if I were to, again, kind of do the mental checklist of what's going on with this one, I'm going to come down, I'm going to bounce. I am going to go through this one, right? And then back up and through this one, and it would end up. So let's go ahead and graph this. Move these arrows out of the way. So it's going to come down, bounce, and then go through. Actually, look, this one goes way down like negative 32 or something. So this is just a rough sketch. So we'll say it goes way down. And then way back up like this. And I think that does end up working. So again, I'm not talking about the turning points this one. The y-intercept, this one you can probably clearly see it's going to cross at 0 since that's what we have in this one. But otherwise, if you want to check out some of those other things in my next video right here, you can do that. And until next time, keep doing your math homework fast and accurately.